welcome to the practice problems video for applied optimization. Okay, so here we have a wire of length 12 meters is being divided into two pieces, and one of those pieces is bent into a square and the other a circle. How can we divide this wire to minimize the sum of their areas? So this one looks a little bit complicated, right? But let's start off by, again, drawing a picture. So we have, let's say, this wire, okay, and it is 12 meters long, it's given, right? So this is like our length L, okay? So 12 meters is the entire length of the wire L, okay? So then what we're going to do is split it at some point. So let's say we cut it here, okay? We're going to call this length X, okay? So we're going to call that length X, and then this length is then 12 minus X, right? Because then when you add them up, then you get a total of 12, okay? So now I'm going to take this X piece, and we're going to bend this one into a square, okay? So then we're going to make a square. So then that means that each of these sides is x over 4, right? So x over 4, and x over 4, x over 4. All right? So therefore the perimeter is all x, right? That's equal to x. And then we're going to make this part here, this 12 minus x, we're going to make that into the circle. Okay, so here's our circle. All right, so there's the circle there. All right, so this has a perimeter or a circumference of circumference is equal to 12 minus x. Okay, so now from this, we can kind of work with what we have, right? So the area of our square is going to be, because we want to concern ourselves with the area, actually the sum of the areas, right? So the area of the square is just simply going to be x over 4 times x over 4, which is equal to x squared over 16. Okay, that was a simple one, right? So I'll draw a little square there for square. The area is square. The square's area. There we go. So that's x squared over 16. But this one, this circle one, that one's going to be a little bit more complicated because we have to deal with a radius, right? So the radius, so all we have to work with is c equals 12 minus x, which, according to the circumference formula, it should be 2 pi r, right? So that means that 2 pi r, so 2 pi r is equal to 12 minus x. So if we want to get r in terms of x, because we just want to deal with x's, right? So r is equal to 12 minus x divided by 2 pi. Okay, so working with this, now we can find our area formula for the circle. So I'll continue this on the next slide. So let's say here's our circle again. Okay, that did not look like a circle. Okay, I'm going to try a little bit harder this time. Okay, so here's our circle. Right, there's our radius, and we have that, we just found that r is equal to 12 minus x over 2 pi. Okay, so then area of a circle is given by pi r squared, right? So if we plug in that value for the r, we get pi times 12 minus x over 2 pi, and then quantity squared, right? So now what I'm going to do is just basically simplify this out. So we're going to factor all of this. So we have pi times, and then we're going to have a 12 minus x squared. So on the top we get 144 plus an x squared minus a 24x. And then this is all over a 4 pi squared. Okay, so the pi's can cancel. So we basically just get that we have an x squared and then plus, well, minus, I'll just say minus the 24x plus the 144, okay, so in descending order, and then this is all over a 4 pi, okay? So this is the area of our circle, okay, in terms of x. So the way we can write the sum of the areas is the following. So sum of areas is equal to, it should be equal to the area of the square, so the area of the square plus the area of the circle. Right? So this is going to be area of the square was simply x squared over 16. So that was an easy one, right? And then we have that the area of the circle is this thing. So 1 over 4 pi, and then times x squared minus 24x plus a 144. Okay? So something like that, which we can simplify on the next slide. Okay? So keep this one in mind. Keep this equation here. This is equal to the sum of the areas. Okay? So we have x squared over 16. I'll actually just rewrite it. So x squared over 16, and then we have a 1 over 4 pi times this x squared minus 24x plus 144. So here I'm going to try to get a common denominator. So we're going to multiply by pi on this one, top and bottom, and then here we'll multiply by a 4 on top and bottom. Okay. So we're going to get the area, I'll just call it A overall, for the sum of the areas is going to equal pi times x squared over 16 pi, and then plus 4 times x squared, and then minus, and 24 times 4 is a 96x, and then plus 144 times 4, which is 576, and this also is over 16 pi. Okay, so lastly we can combine the x squared terms, so we have a pi plus 4 times x squared, okay, and then this is minus a 96x plus 576, and all of it is over this 16 pi. Okay, so now that we have this area formula, what we can do is basically just take the derivative. Okay, so now we're going to optimize this. So we'll start that on the next slide so we have enough room there. Okay, so a of x is equal to, and then we're going to have this 1 over 16 pi. I'll move that in front now, okay, so we don't have to deal with it later. Then we have pi plus 4 times x squared. Then we have this minus 96x plus 576. So some big numbers in there. But what we're going to do is just differentiate once. So according to the chain rule, constant multiple rule, we just have that 1 over 16 pi just sitting in front there. And then inside we can bring down that 2 in front, so 2 times pi plus 4. Then we're left with an x minus a 96, and then this 576 goes away completely. Okay, so we're left with something like that. And now what we have to do, all that is basically just setting this equal to 0. So we find that critical point, right? So then if we multiply by 16 pi on both sides, that just goes away. And times 16 pi, that's still 0. So then we have 2 times pi plus 4 times x minus 96 is equal to 0, right? So this is equal to 0. So a prime of x is equal to 0 when we have that x is equal to a 96 over 2 times pi plus 4, okay? So that's going to be, basically this will reduce to a 48 over pi plus 4. Okay, so then we have that x is about equal to a 6.72 meters. Okay, so then remember x was how much went to the how much of the wire of the original 12 meter length wire went to the square. So this is to the square. Okay, and then whatever was left over, that was 12 minus x. So that means that our 12 minus x is going to be 12 minus 6.72, which is equal to 5.28 meters. Okay, so this one here, that's how much should go to the circle. Okay, so that's basically it. That's our answer. That's how we should divide up that 12 meter length wire in order to minimize the sum of the areas. I just want you.